welcome back. Today's vlog, I am going to introduce you to a storage study that we have been able to conduct here at the Wisconsin Potato and Vegetable Storage Research Facility starting from last September. I will be introducing you about the objective of the study, how we do it, and what we get so far from the study. So now let's get inside. So now we are looking at the control panel of those bulk beans at Hancock. There are totally 8 beans here, and we can see them listed here on the control panel. Our potatoes are stored in bin 7, which is this. Currently it is stopped because we want to stop the airflow to be able to use the thermal camera. We don't want any airflow during thermal camera scanning. So if we click on bin 7, we are looking at more details. So the temperature is at 48. The humidity SP means set point is 95%. The plenum, which is a true humidity inside of the bean, is 98.3%. CO2 set point is 2000, and right now it's 1800 parts per million, which is lower than the threshold. And these are some other parameters. So now let's go to the storage bin number 7. I am standing in front of the bulk bin here, and you can see the sign here that's Rusty Burbank and my name on that. This bulk bin can store up to I think 20,000 hundredweight of potatoes. But this is relatively small scale compared to the commercial storage bin. And now we will have Sam open up the bin, the door of the bin for us. Okay, Sam. We can see the wooden stakes that's being lined up in front of the pile. And inside of the wooden stakes and the wrap, we have those rusted Burbank potatoes. Top of the pile is 12 feet high, compares to the 18 feet high of the commercial storage facilities. And now we are going to walk to the top of the pile. This white line here indicating the top of the storage pile when we loaded the bean. So this is 12 feet high when we start the storage season last September, and this is where the top of the pile is, meaning that we lost some weight of the pile over the last, I think, 7 months. The weight loss is caused by the respiration and transpiration of the tubers during storage. And based on previous studies, it shows that transpiration, which is the loss of water from the tuber, takes up about 98%, and the rest of the 2% is caused by the respiration of the tubers, which is the biomass loss. Overall, the tubers are pretty healthy just by looking at them on the top. Those cables are the thermometers, and we want to make sure that the delta T, which is the temperature difference of top of the pile and bottom of the pile, is about 1 degrees Fahrenheit. Next, I want to mention how we designed this study. So last September, when we loaded the bean, we manually buried 40 pounds of tubers inoculated by pink rot. I think in 3 different spots. One is over here One is over here, and I think the other is over here at 2 feet deep. And the objective of the study is to use 2 types of thermal camera over the storage season and trying to investigate, can we tell the hot spot or the disease, where the disease tubers are. The first camera is the Fluky TI400. This is a more sophisticated industry used by the plumbing technicians. So this is about $8,000, so very costly. And we want to use this camera to scan through the top of the pile, and we want to see if we can tell where the hot spot is from the camera. So we came here on a monthly basis ever since we loaded this beam, and so far we can't tell where the hot spot is. So remember, on the thermal camera, the yellower or the redder the color is, the higher the temperature is. The other camera we're trying is the Flare Pro, which is this one. This one is more handy. We can just easily attach it to a smartphone, and it serves the same purpose. So whatever shows on the camera is the temperature released from the surface of the objectives. So in this case, it's the potato tubers. So again, we're looking for a redder or yellower color. But overall, these temperatures are pretty consistent. I think the storage temperature here is right now is 53 temperatures Fahrenheit. The underlying thought of this study is that because we have those diseased tubers, they're supposed to release more heat compared to the healthy tubers. And then we want to see if we can detect the heat on the thermal camera. But unfortunately, so far, it's after 7 months and we still can't see anything. So our hypothesis is that those tubers, even they are inoculated here at the Hancock Research Station, the airflow is too ideal, and all the hot spots have been dried out. And we have not seen any further spread of the disease from the inoculated tuber to the rest of the pile. So that's good news or bad news. Good news is that this whole pile donated by industry collaborator, the whole pile has been kept at a very good level of quality, and I think they will be able to unload this beam pretty soon and ship them to the processing plant and then process them into frozen fries. But for us as researchers, we are not able to get any good results so far. So I think next step is to try to increase the amount of diseased tubers from 40 pounds to 1,000. This coming fall, we are going to bury a much larger quantity of diseased tubers under 2 feet below the pile surface, and we want to try if that larger scale of hotspot or disease tubers can cause more heat released that can be detected on those 2 types of thermal cameras. And that will provide the growers or the storage managers a tool to be more preventative and proactive to get rid of the loss caused by storage disease or hotspots during the storage season. So that's for today's video. I hope you enjoyed it. I will see you next time. Thanks. So I just got a word from the donor collaborator that those potatoes in bin 7 will be unloaded tomorrow starting from 8 a.m. and I think they will need about 4 truckloads to unload the whole bean